In this video, we'll be identifying the 4 functions of a computer. We'll also be explaining what a programming language is, why it's used, and the 3 different types of programming languages that exist. And then we'll be explaining the difference between a compiler and an interpreter. So regardless of the computer type that you have, there are 4 main basic functions that every computer can do. And this works for things like phones, things like the smart devices in a car, things like your laptop, anything that is like a computer that has a computer chip in it does these 4 things. And the first thing that a computer can do is it can take in input. And in the slides to come, we'll be describing this in more detail, but a computer can take in input. It can take in information, and then after that, what it can do is it can process that information. So a computer must be able to take in input in some way. It then processes that information that it's been given in some way. It can also store information. So it takes information in, it can process that information, it can store that information for use later, and then it can output information as well and send it back out to the users. We're going to go through these 4 in a little bit more detail, but it can input, process, store, and output. So the first thing that every computer can do is it can take in information from its users. And there's a lot of different ways that a computer can take in information. Now, if you're thinking of a traditional laptop or, desktop device, you'll know that you can take in information, or a computer can take in information using a mouse and using a keyboard. Those are probably the most obvious ways. You type on your keyboard, you move around, and you click your mouse. Now, there are other ways that other types of computers can take in information. If you think about the fact that a lot of you use your phone and you talk to Siri on your phone or Google on your phone, there are a lot of different audio versions like a microphone that can allow computers to take in information as input. So then audio would be another type of input. You can also use things like controllers to press buttons. You can also use things like a touchscreen. So a lot of you use touchscreens on your phones. Touchscreens are also types of inputs. There's a lot of different ways that computers take in input, and it's how they take in information from the person that is using that device. Now, the second thing that computers can do is that they can process information, which means they do something with the information that's been given to them. Now, there are an infinite number of things that computers can do when they process information, but a couple of examples that you might think of is when you use your keyboard, you type characters onto a document. So maybe you're typing characters onto a document. Maybe you're using your voice and your audio to open up a file. Or maybe you're using your controller to race in Mario Kart, because that's my favorite game that I play on a video game, so that's what I use a controller for. But there are infinite number of do somethings that your computer can do, and it really depends on the software you're using and what you're trying to get done. But what your computer does when it processes information is it takes the input that you've given it and it does something on your particular computer. Now, thirdly, all computers can store information in memory. And there's a lot of different types of memory that you might have. Some of you might store information using that hard drive on your computer. You might store information using, a memory card on your phone. You might store information using a flash drive. But all computers can in some way store the information that they're given. So there's a lot of different ways that they can store that information, but it's so that information can be used later on. And then lastly, computers need to be able to output information for the users to see. So while it's great that they can input information and process the information, you have to be able to output it so the user can see that what they ask the computer to do is actually being done. So ways that things are outputted is they're outputted via speakers. So sometimes you're asking it to, play music or something like that. It can output via speakers. It can also output via a monitor, so that's how you visually see things. It may also output via things like a printer. Say you want to actually print a device, you can actually output and print items elsewhere. And finally, another type of output that you'll see is if you like to play video games and you use controllers, any sort of vibration on a controller is also an output. So there are lots of different ways that your computers can output information to you. These on the screen are just 4 different examples of ways that you might hear, see, and feel different outputs that a computer might send to you. So now that we've mastered what a computer can do, let's talk about a computer program. And a computer program is a planned sequence of instructions. So these are the instructions that we're going to write when we create our own computer programs. And computer programs tell computers what to do, so what steps to perform, and when to perform them. So it gives an order, and then it gives the actual steps that need to be performed. Now, computer programs are also known as software. So you've probably heard of hardware and software. Hardware are the actual hard physical components of your computer, and softwares are the programs that you actually put onto your computer that you run. So programs, as I said, are planned sequences of instructions that tell your computer what to do and when. Now, programming languages exist so that we can actually write instructions for a computer. And while it would be really great if we could just, in English, tell our computer exactly what we want it to do, it's a little bit trickier than that. So computers follow instructions exactly. Computers are not smart. They are not like humans. They cannot interpret any type of meaning in any words. So they follow things exactly, very, very literally. And if you actually take a look at the English language, English is incredibly confusing. So there are some words that have multiple meanings, like lead and lead. Lead is a type of metal, and lead is an action, but they're spelled the same. And it makes English very confusing, and it makes computers not know what to do with that. You also have some words that sound the same, but have completely different spellings with different meanings. So think of two, and two. They sound the same. So if we were to just, in English, tell our computer what to do, it wouldn't know what to do with that. It wouldn't know what to do with the different versions of two. It wouldn't know what to do with the fact that these words have the same spelling. So because computers need to follow instructions exactly, and there can't be any things that are confusing that need to be interpreted, we have programming languages that tell computers exactly what to do and give them very exact, clear, concrete instructions. Now, the benefits of a programming language is that in computer programming languages, each word has exactly one meaning. So the computer is not going to get confused. It's going to read the word, it has one meaning, it's going to complete that action. Computers will know exactly what to do when you use programming languages because there's no need to interpret anything. They will do exactly what the programming language says because each word has one meaning. So there are 3 types of computer languages that we're going to talk about. The first are high-level languages, and these are the ones that are used typically by programmers. And we're going to talk in detail about why that is, but those are the ones that we typically use. Assembly language is a middle-level language, and then machine language is what the computer can actually read. So we're going to talk about these 3 different types of computer languages in general. So high-level languages are really easy for us programmers to use because they're similar to our everyday language and symbols. They're very, very similar to the English language that we speak in. Now, they're not exact, and there are very, very clear, specific words that need to be used, but we pretty much understand what they use, and it makes sense to us as we write the code. The other thing that's nice is that high-level languages are portable and can be used on different types of computers. So they can maybe be used on a Mac operating system or a Windows operating system or a Linux operating system. It doesn't matter which type you're using. They're portable and they can move to different types of computers, which can make a difference, especially if you have programmers on different types of computers working together to write some code. Now, the tricky part about high-level languages is they must be translated because computers are not really able to read high-level languages. They have to be translated down to a low-level language so that the computers can actually read it. But the nice thing is there's a way to convert these high-level languages down to low-level languages that computers can read, and so that's why we like to use them. Now, there are many, many examples of high-level languages. To name a few, Python, the one we're going to use in our course, is a high-level language. Java, which is what's taught in AP Java, is another high-level language. Then you've got things like C#, C++, C, Visual Basic. There are many, 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 many more beyond this, but there's a lot of high-level languages that programmers use. These are just 6 popular ones, and as I said, this Python one is the one we're going to be using in this course. Now, assembly language, which is typically a mid or low-level language, can be used by programmers, and it does use some everyday language, so it does use things that resemble English, but it's a little more explicit. So for example, if you look on this slide, you'll see some code that's written in assembly language and high-level language, and you're going to see how assembly is basically a little bit lower level than high-level language. So in this particular statement right here, what's happening is we're taking a variable for A, whatever its value is, we're adding it to B, and then we're taking this value and we're saving it inside of C. That's what this high-level line means. It takes one line to do this. Take what A is equal to, add it to B, save it in C. In order to do this same exact action in assembly language, you would have to load A in the first line, add B in the second line, and then store that value in C in the third line. Now, it does the same thing as this line of high-level language code, but first, this is a little bit more difficult to write, and it takes 3 lines to do it. So while we can write in assembly language, we like to focus on high-level languages because they're just a little bit easier to write with. But assembly languages can also be translated into that machine language, which is what you're going to have to translate things into in order for a computer to read it. Now, machine language, which is our third and final type of computer programming language, is the computer's native language. It's the only thing that computers can actually understand. So every high-level program, any assembly-level programs, must be translated into machine language in order for the computer to read it. Computers consist of binary code, which is just zeros and ones. And so this is an example down here of what machine language looks like. Now, there's different combinations of zeros and ones that represent different letters, different numbers that the computer can actually read. But we don't want to write this out. Can you imagine coding every single letter, number, instruction that exists into this? It would take us forever. But the reason that this is the only thing that computers can read is because computers can only read essentially on and off switches. An on is a 1 and an off is a 0. It can't actually read letters and things like that. It can either read that something is on, a 1, or something is off, a 0. So that's why we use the zeros and the ones in machine language. So we have to be able to convert things into machine language, but we use this because computers can very specifically read if things are on or things are off. Now, there are 2 different ways that high-level languages can be translated into machine language. One is called the compiler, and one is called an interpreter. And on the upcoming slides, we're actually going to walk through compilers and interpreters and how they're similar and how they're different. So a compiler is one way to translate a program from high-level language to machine language, and it's used by languages like C++, Pascal, and Java. And what a compiler does is it translates the entire program from high-level language to machine language. It does the entire thing and then runs the program. Now, where this has benefits is it can actually detect multiple errors at one time. Because you're translating the entire program, you can actually detect more than one error at a time. However, where this gets confusing is if you're not careful, there could be, because of one error, something that is actually caused by one error, but because you're translating the whole program and that one error is occurring, it's causing, maybe 50 errors in your program. So it makes it a little bit more difficult to locate the error sometimes. Not always, but sometimes. But the nice thing about a compiler is it translates that entire thing. You can see all of the errors. You can fix all the errors at once and then go back and run your program. And as I said, it's used by C++, Pascal, Java, and many other languages. Now, an interpreter is similar. It translates high-level languages into machine language, but what this does is it translates one line at a time and then runs one line at a time. So there'll be different lines of code, and it'll go through, it'll translate line 1, run line 1, translate line 2, run line 2. Now, if there's an error in, say we have here 5 lines of code, so we've translated line 1, it runs. Translated line 2, it runs. If it translates line 3 and it finds an error, the program stops. And so while you can't test the entire program at once, what's really nice about interpreters is it stops immediately when it finds an error, and it wants you to fix that error before it's going to move on. So that's where this can be nice, because it can help you to locate exactly where one big error is occurring, and you can fix that one error and then move on. Languages that use this type of translation are BASIC, Visual Basic, and Python, which we'll be using. So keep in mind, Python translates one line at a time. So as you run your programs, it's only going to show you one error at a time, but it'll help you to fix your errors a little more quickly, one at a time, because you'll be able to locate fairly easily where that error is occurring. Now, the Python programming language, which we're going to be using in this class, we're just going to take a couple quick little notes on it so we have some background knowledge on Python. So it was created by a man named Guido van Rossum, and it was released in 1991, so it's only been around for about 30 years. It's an interpreter language, as we talked about on the previous slide, and it focuses on easy readability, and that's why people really like to use it. It's just easy to read, easy to figure out what it's supposed to do, easy to write, because it just is easy for programmers across the board to use and read. Now, some fun facts about it is that it's called Python because the author really liked this British comedy group called Monty Python, and so he named it after them. And then idle, which is where if you don't use the online version, if you actually download the software and put it onto a Windows PC or a Macintosh computer or something like that, idle, IDLE, where the program runs, is called Integrated Development Environment, is actually named after Eric Idle, who's one of Monty Python's founding members. So it's kind of cool that Guido van Rossum tied in, his favorite Monty Python comedy group into the name of his programming language, and then named the program where it runs, idle, after one of Monty Python's founding members. Now, a couple of key details to know when you're working with the Python shell, especially if you're using graphics, are that the dimensions of this particular window vary depending on how large you make that window. The middle point here in the middle of the screen is always going to be 0, 0. And then the rest of this works like a coordinate plane. You can actually give it coordinates to go to, like 100, 50, and it will go to 100, 50, plot it, and you'll find it there. So just kind of keep that in mind, that when you move around that window, if you're using graphics, it's going to work like a coordinate plane in your math class. Now, as we start writing our first programs in Python, you will be expected to comment. It's a very, very important part of the programming process because it can help others read and comprehend your code, which is really important for people like your instructors or other students in the class if you ask them for help, or if you decide to do this as a career, if you have colleagues that you're writing programs with, or you have somebody who wants to interpret and check over your program. So if you include comments, others can read and comprehend what your code is supposed to do. Secondly, if you use commenting, it's easier for you to find your own errors. If something occurs and you know what the output is supposed to be, but it's not occurring, you'll be able to go in and read through your code, and if you have good commenting, you'll find your errors a lot more quickly. And lastly, it'll remind you of the purpose of each line of code, which might not seem like a big deal, but for those of you that aren't writing programs straight through in one sitting, if you wait over a weekend or wait to the next day, having that commenting in there is going to help you as you try to remember what each part of your program does. Now, you will be required to comment your code, so make sure that in the next slide you take note of how you comment, because you will be required to comment, and to comment a lot, in order to receive full credit for your programs. Now, there are a couple main ways that you can comment. The first is you can do a single line comment by using the hashtag symbol. So you'll have your lines of code, have your lines of code, have your lines of code, and say you want to put a comment before them. If you just put a hashtag, anything you put after this will be commented. So the program won't actually read it, but it'll be a comment for you, a reminder for you of what that purpose of that chunk of code was. Now, the second way you can comment is you can do a multiple line comment. So if you know you're going to write multiple lines worth of information, what you can do is put 3 sets of double quotes, write all your comments, and then do 3 sets of double quotes again to end it. So this whole chunk wouldn't be read by the computer because it would be a multiple line comment. So you can see down here we have the 3 different types. First, this comment at the top is a multiple line comment because I'm using it to, make some notes about the purpose of my program. But down here, I use the single line comment because I just wanted to put a comment after my first line of text to tell me that this is going to print hello to the screen. So we have 2 types of commenting that you'll need to be able to use, single and multiple line comments. And last but not least, where do our comments typically go? Well, there are 3 places you'll want to have comments. First is you'll want to include comments at the beginning of your program. This typically gives your program a name, so it's the name of your program and what it's supposed to do. This will typically have your name, maybe your, if this is for a class, maybe your teacher or your hour or something like that. It'll also often have the purpose of your program. So that'll all be in your introduction, the beginning. You'll do typically a multiple line comment with those 3 sets of double quotes, put all your information, and end it. Now beyond this, you'll also do single line comments, or maybe, a couple lines of comments to help you summarize the purpose of lines of code. So say you have, 2 lines of code here, and they, maybe they print something to the screen or they do a math calculation. You'd often either put a single line comment before them, so you can do a single line comment here, or you can do single line comments right afterwards and write your comments in there to explain what each line of code does. So including those comments throughout your program is going to summarize what's going on as you code. And finally, you'll often have comments to end or conclude your program. For this course, you'll have some summary questions you have to answer, so typically I ask that you do the triple double quotes again, and you put all of your answers to those questions inside of them to end your program.